So we are given I of t equivalent to 432 minus e to the negative 10t milliamperes. And then we have I2 of 0, or the initial value of I2 is equivalent to negative 1 milliamperes. Now, first, let's solve for I1 of 0. How do we get the value of I1 of 0? So first, let's apply KCL at this node. So let's label this as node A. So KCL at node A, we have I is just equivalent to I1 plus I2. Now we are given the value of the initial value of I2, and we are given the equation for I of t. So we can solve for the value of I of t at t equals to 0, or at the initial time. So we have at t equals to 0, we have 4 quantity 2 minus e to the negative 10 times 0 equal to I1 of 0 plus I2 of 0 is just negative 1. So this is in milliampere. This is milliampere. I of 0 is just equivalent to, so we have 2 minus e to the 0, which is e to the 0 is just equivalent to 1. So we have 4, which is milli, equal to I1 of 0 minus 1 milli. So solving for I1 of 0, we have 5 milliamperes. So next is solve for V of t. Next, solve the expression of V1 of t. So since we are given the expression for I of t, V1 of t is equivalent to 2 times di per dt, which is equivalent to 2 times 4 times 10e to the power of negative 10t, which is equivalent to 80 e to the negative 10t millivolts. So next, solve for expression V2 of t. So how do we get the value of V2 of t? Now since we have the expression for V, then we have the expression for V1, we can apply KVL at this loop to solve for V2. So KVL at 1, we have negative V of t plus V1 of t plus V2 of t equal to 0. So we have these values. So V2 of t is equivalent to 120 e to the negative 10t millivolts. So next, solve for the expression of I1 of t. So how do we get the value of I1 of t? Since we have the expression of V2 of t, we all know that we can relate the current in an inductor to the voltage using the equation I is equivalent to 1 over L integral of V dt plus initial value. So this is from integrated from t naught to t. Now for I1 of t, we have 120 over 4 integral of e to the negative 10t dt evaluated from 0 to t minus, so the initial value of I1 is 5 milliamperes. So this becomes negative 3 e to the negative 10t evaluated from 0 to t plus the initial value of 5 milliamperes. So finally, the expression I1 of t is just 8 minus 3 e to the negative 10 t milliamperes. So similarly, we can get I2 of t using the same process. We have 120 over 12, we have e to the negative 10t evaluated from 0 to t. And the initial value of I2 is negative 1 milliampere. So this becomes negative e to the negative 10t evaluated from 0 to t minus 1 milliampere. So finally, we have negative e to the negative 10t milliampere. So we can verify our expressions using the initial conditions. So using this, so take a look at I2 of t. So we all know that I2 of 0 is negative 1 milliampere. So using this expression right here, at t equals to 0, this value becomes negative e to the negative 10 times 0. We have negative 1 milliampere. Now for same with uh, I1 of t. So we'll know that the initial value for I1 or I1 of 0 is 5 milliamperes. So using this equation right here, at t equals to 0, this expression becomes 8 minus 3 e to the negative 10 times 0 is equivalent to 8 minus 3 equivalent to 5 ampere. This table shows the summary of the important characteristics of the basic elements. We have a resistor, capacitor, and then inductor.